welcome to BKW Physics. I'm Mr. McConley. Today we're going to talk about Millikan's oil drop experiment with Robert Millikan. And what he basically did is this. He set up a parallel plate capacitor, which we previously learned about, which has two conductors, and these conductors are separated. And you hook the two conductors to a source of electrons, like a battery. And when you do that, one of the plates becomes charged negatively, and the other plate is charged positively. Now, the next thing he did is he actually had an atomizer, which some of you might just call, oh, that's like just a perfume bottle or something like that. And you know, old-fashioned perfume bottle where you squeeze the thing on the end here and it sprays a mist of the perfume out into the air. That's called an atomizer, but he used it a little differently. He actually put oil in the perfume bottle, and so when he squeezed the bowl, it sprayed out a mist of oil. Now this process of spraying out the mist is important because as the little oil droplets leave the nozzle, they are charged because of friction. Okay, it's a small opening. So they're charged because of friction, and actually these you can think of as little negative charges. So you're misting a bunch of negative charges out into the air. Now, he actually had in his apparatus here, in his parallel plate, he actually had a hole drilled right here. Now, it wasn't this enormous, but I'll just, you don't even have to draw it on your picture. Just know that there's a small hole there. So some of these little negatives, a lot of them just, you know, go here and there, but some will actually fall through the opening. So here's one, let's say, that fell through the opening. So these are falling, and what's pulling them down is the force of gravity. So you have the force of gravity acting in a downward direction. Now once that little negative drop gets in between the parallel plates, now there's another force acting on it, which we learned yesterday. Electric fields coupled with the charge will actually produce a force. So the way we wrote it was E equals F over Q. That was yesterday's reference table equation. But when you rearrange it, basically if you know the electric field and you know the charge, you will also produce a force. But in this case, the positives here and the negatives here, so when you turn up the electricity and it produces more of an electric field, which way is the force going to be on this negative? These are positives, so it's going to be pulling it down more. So at this point, you know what I know? I drew my picture upside down. So all I want you to do here to change your picture, because I wasn't really thinking this through, I guess the negatives have to be on the bottom, the positives have to be on the top. Sorry. Yeah. Well, once I looked at it, it didn't make a lot of sense. So this electric field is now going to be in the up direction. Now furthermore, he actually had a way where, like, we'll say just draw it as a dial or something like that. He could turn up the power or turn down the power. Now, what he was doing is he was actually using a scope, you know, like a microscope, but I'll draw it like it's a telescope or something. And he's over here and he's looking at this situation. Here's Mr. Millikan. All right, he was a good-looking guy. You can tell by my picture. So Mr. Millikan is looking at this scope, and with this scope, he can actually see that little oil droplet in between the two parallel plates. And when he sees that oil droplet, he sees it falling. If it's falling down, he turns the knob and gives it a little more power. And then if it's rising up too fast, he turns the knob back down until eventually he gets the knob in the right spot and it floats. Exactly. So gravity and the electrostatic force are canceling out, and that negative will float right there. Well, then what he can do is he can start writing down some information. He starts kind of making a chart. Well, I know that the electric field was this strong because he uses the information about the battery and the amount of electricity he's sending. And I'll teach you more about that later. But he said, okay, I know the electric field was this strong. And I know that the force of gravity is this strong. And so what he ends up doing is he makes a table. And he starts collecting information. He repeats this experiment many times. And all the while he's thinking to himself, well, Fg can be set equal to the F of the electric field. So in other words, mass times gravity is going to equal E times Q. Now what he's getting at here is he is looking for the charge of an electron. He's looking for the charge of this negative. He's wondering what this charge is. But here's the problem. Is this one electron, when this little negative drops through here, does that represent one electron? No. This is like, I don't know, thousands or millions of electrons. It's in an oil droplet, so there's a lot of electrons there. So when he gets these numbers, he starts getting values for Q. These numbers are not the charge of one electron, but all of these numbers are multiples of the charge of an electron. These are multiples of the charge of an electron. So what might these numbers look like? All of these numbers are 1.6 e negative 19 times something, like times 2, times 3, times 100, times 1,000. All these numbers are some multiple of this number. And he eventually figures out, he works backwards, and he figures out that when he looks at his list of numbers for charges, every one of them is divisible by 1.6 e negative 19. And when he figures that out, Mr. Millikan has found the charge of an electron. So Mr. Millikan is the guy that realized that 1.6 e negative 19 coulombs is one elementary charge, or the charge of one electron, if you like to refer to it that way. So he has found the charge of an electron using the Millikan apparatus right here. And this is an experiment that people have repeated many, many times, and I actually was able to do it in college. It was very fun to do. So for today, we have found the charge of an electron. Physics.